Hello and welcome to part 7 in this Orbiter tutorial series. This is Tex again, and this will conclude our flight that we have done so far in the default Delta glider from Cape Canaveral up to the International Space Station, and now we're getting ready to land back at Cape Canaveral. In the previous part, I showed you how to find a landing window while you're in orbit and then perform the deorbit burn so that we can re-enter. Now we did install a couple of add-on MFDs. They are the Base Sync MFD and Glideslope MFD. I'll put a link to those in the description box of this video and also the previous part. Also, if you didn't see the previous part, we did set up those MFDs, particularly the Glideslope MFD, which you will need to do if you're going to follow along with our reentry, because we're going to be using that Glideslope MFD throughout the reentry and landing process. Alright, so with that said, let's go ahead and jump into Orbiter. I already have it running here. And you may notice across the bottom it says replay. Now, what I've done is I've used Orbiter's record and playback feature to actually record my reentry and landing so that I can play that back. And I can better explain what's going on by doing it this way. Because the default Delta glider does not have an autopilot, I found it was incredibly difficult to manually fly the reentry with the joystick and everything while attempting to explain what's going on to you guys. And I wanted to fly a relatively good reentry and landing so that you could see, you know, kind of a proper profile for that. So anyways, let me unpause and we'll go ahead and proceed. What I'm going to do is open Glideslope on this side as well. Alright, I'm going to press mode until I get to this screen right here. Now I've gone to rotation RCS and I'm going to rotate inverted, and I want to point the vessel right at the velocity vector as indicated on the surface HUD. Once I have done that, I'm going to press the autopilot button here on the Glideslope MFD. Now that's going to hold our Delta glider at about a 41-degree angle of attack. And ideally, we would want to be right side up and pitch up 40 degrees and hold that type of an angle of attack as we enter the atmosphere. Well, the problem with the default Delta glider is that it just can't do that. So what will happen is if we were right side up and we were pitched up 40 degrees, as we fell into the atmosphere, the wings would start generating lift, and the Delta glider would want to climb up and then skip out of the atmosphere. So right now what I'm doing is I'm inverted and pitched down 40 degrees with this autopilot just through entry interface until we get control of our vertical acceleration. Now I'll go over all these numbers here in a bit, but just take a look right here. We see vertical acceleration, vertical speed, and altitude. You'll notice that, and again, if I open the surface MFD over here, it's the same thing. Here's vertical speed, vertical acceleration, so this is the rate of our vertical speed change. You'll notice that vertical acceleration is a positive number. So what that's doing is that's slowing down our rate of change here on vertical speed. And obviously we want to descend through the atmosphere. So if I were to pitch up, this vertical acceleration number would climb higher, and eventually vertical speed would drop to 0, and then it would move to a positive number and we would no longer be descending. So by being inverted and pitched down 40 degrees through entry interface, I'm making sure that we get down into enough of the atmosphere that I get control of the vessel with the airflow control surfaces. And once I'm in the atmosphere enough that I have control of the vessel, I can control our vertical speed to ensure that we don't skip out of the atmosphere, but also ensure that we don't descend too quickly and theoretically burn up. Because even though the default Delta glider doesn't simulate burning up per se in the atmosphere like say the XR2 does, we're going to try to fly this as realistically as we can. Alright, let's hop back over to Glideslope over here, and let's take a look at this. So this is the vertical situation mode. You can press mode until you get to that. What we have here is our true airspeed. The green trace is our true airspeed reference, and the yellow trace is our altitude trace reference. So when I talk about reference, I'm talking about this is essentially our planned trajectory down through the reentry. So currently up here we're at orbital velocity, And then as we fall through the atmosphere, our speed is going to dramatically drop as we slow down. Same thing with our altitude. You know, we're coming down from orbital altitude, and then as we descend through the atmosphere, our altitude is going to constantly decrease. And then both of those converge down here at the base, Cape Canaveral, runway 33 down here. So the bright yellow is our actual altitude right now in real time, and you'll see it's projecting out this way as our flight progresses. And the same thing with the green, this is our true airspeed, our actual true airspeed. So ideally what we want to see is throughout our descent, throughout the reentry, we want to keep our true airspeed and our altitude pretty much overlapped with the reference there. So if we can do that, then we are flying our planned reentry trajectory down to the runway. But we also need to consider our bearing to the base. What this does, if we keep our speed and our altitude in line with the planned trajectory here, well, this will ensure that we manage our energy in such a way that we don't overshoot the base and we don't fall short of the base, because there's nothing more frustrating than looking out of your window and you see the runway below you, but you're still doing 3,000 meters per second. If you're a beginner and you've experienced that, then you know how frustrating it is. Or worse yet, you look out the window and you're over Texas and you're doing like 200 meters per second, so no way you're getting there without using your engines. So anyway, this ensures that you manage your energy in such a way that you can actually reach the base. But you also need to consider your bearing, because once again, we used the base sync MFD in the previous part, so we're pretty much heading right toward the base. We're barely missing it by 3 kilometers at the moment. But if we start doing S-turns like we're going to have to in the atmosphere to slow down, of course we will begin turning away from the base. So you need to time it in such a way that when you're done doing your S-turns and you've slowed down, that you're pointed back at the base. So you could actually see that here on the base sync MFD. As you do an S-turn, the distance would increase, and then you could turn back the other direction to bring the distance back down. But we don't really need to look at that, because we can look at here, delta azimuth. So this is giving us, it's actually saying 2.8 degrees right now. So if we have delta azimuth right on 0, we're essentially heading toward the base. What we're actually heading toward, though, is called the HAC. It's the heading alignment circle. And what it is it's just a circle that you perform right by the base in order to scrub the last little bit of energy and altitude that you have so that you can come around and land on the runway. It's something the space shuttle does. They like to come in with a little extra energy just, for safety reasons, in case there's high winds or something goes wrong. They'd rather get there with a little extra energy and then have to scrub it off by doing a circle before landing. So above at the top, you can see HAC that I talked about, the heading alignment circles. This is telling us our distance to the HAC. So we're 5,500 kilometers. That's million meters. So same thing as kilometers. 5,400 kilometers from the HAC, and the HAC is right near the base. So we're quite a ways away still, obviously. In fact, if I look at the map MFD and we zoom in, you can see we're fixing to cross the west coast over into Canada. All right, and then finally here is delta reference total energy. This is just the percentage of our total energy. So this takes into account the sum of our potential energy from our altitude and our kinetic energy from our airspeed. So this percentage, we just use that to monitor our overall energy state and trend as we come down through the main descent. All right, let me jump over to Glideslope again. And so you'll notice that what happened is our vertical speed actually got into a negative number. I wasn't over there for you to see it, but our vertical acceleration, dropped to a negative number, and our altitude is now at 81 kilometers. So we're now low enough in the atmosphere that I can keep control of the vessel with my airflow control surfaces. Actually, we still need RCS at the moment, but we're low enough in the atmosphere that I can adjust my vertical speed, because there's enough air flowing over the vessel that I can make these adjustments as needed in order to make sure we don't skip out of the atmosphere or descend too quickly. All right, so now what I'm doing is I'm going to perform our first S-turn. So I'm rolling over. It doesn't matter which way you roll if you're already pointed at the base. So I'm just rolling over this direction, because if you take a look at our true airspeed here and where the reference is, it begins to decrease. It starts curving down right there. So that's telling me that we need to definitely be slowing down. So I've rolled over, and I'll put full trim up like this so that it helps me pull back on the stick a little bit more. So while we're rolled over on the side, I'm pulling back on the stick, and I'm trying to expose as much of the underside of the Delta glider to the air as I can, to the air molecules, in order to slow down. So I'll actually monitor our altitude here and our true airspeed here, and just try to keep those perfectly in line with that reference there. So if we can keep these perfectly overlapped, then we're in good shape. And again, obviously, because we're turning away from the base now, our delta azimuth is climbing away from 0 degrees, but we're not worried about that. We're going to turn this way for a while, then we'll turn back the other direction. And I don't know if you could hear that, but a moment ago she said attitude off. Because we're low enough in the atmosphere, we have enough dynamic pressure now, we don't need RCS anymore, so I've turned RCS off. So we're purely using the airflow control surfaces to control our vessel. Alright, so let's move over here to the digital descent data mode and take a look at these numbers. First of all, on the right side we have a list of reference numbers, and this is telling us where we should be, what our parameters should be at this current point in our flight. Beginning at the top, we have delta azimuth. Again, we saw that down here. This is the actual number, so if this is 0, we're heading right towards the base, or right towards the hack technically. Angle of attack, this is telling us what our actual angle of attack is. The reference is 42. We're supposed to be at a 42-degree angle of attack, but the Delta glider just won't hold that. So the number's red because we are below what the reference is. If the number was green, then it's ideal, and if the number's yellow, then we're high. We're above the reference. You can see that right here with the delta azimuth, actually. So I'm not going to concern myself too much with the angle of attack, because there's not a lot we can do with that with the Delta glider. We just have to do these S-turns as best as we can, roll over, pull back on the stick in order to slow down. So you'll notice as we're doing this S-turn and I'm pulling back on the stick, I'm trying to keep control of our airspeed and bring our airspeed down with that planned trajectory. All right, moving to the next line, we have range right there. That indicates, this right here indicates our range to the touchdown point, and this right here indicates our range to the hack, to the beginning of the heading alignment turn. We'll see that all when we get there. I'll show you that. All right, so we're doing a roll reversal over to the other direction now. Our delta azimuth increased up to 10 degrees, so we'll turn back the other direction. If we take a look at base sync, you can see we turned over 400 kilometers off from the base, and now we're turning back the other direction. So of course that distance is coming down. All right, so below that we have energy here. So what energy is it's the total energy of our vehicle right now. Over here on the right side, this is telling us what our total energy of our vehicle should be at this moment in time. So we're over the mark by a little bit, but the number's still green, so it's still considered ideal. And again, that total energy is considering potential energy and kinetic energy. The delta energy is just the change, and this is telling us what our actual change or what our actual delta energy is now and what it should be. And then down here, these should be pretty self-explanatory, but here's our actual altitude right now, and this is what our actual altitude should be. I'm sorry, this is our actual altitude now. This is what our altitude should be right now. This is our actual vertical speed, and this is what our vertical speed should be. And this is our vertical acceleration, what it should be, and then true airspeed here, what it is now, what it should be, and the rate of acceleration of our speed. So again, altitude listed here, our actual altitude and what it should be, and our true airspeed and what it should be is graphically illustrated over here. So this is really convenient, the vertical situation screen. During your reentry, you can just glance in this and you can quickly see, oh, well, I'm a little bit fast because this bright green line is over our planned speed profile. or here I'm a little bit low. But honestly, this is fine. We're close enough with this right here. Flying a manual reentry is incredibly difficult to keep these spot on all the way down. Okay, so but you can notice what I'm doing is while I'm doing this S-turn, sometimes, you know, like I rolled to the left a little bit there, you could see that. Now I'm rolling to the right a little bit, and then I'll hit kill rotation. What I'm doing is I'm adjusting my vertical speed while I'm in this S-turn. So if I roll to the right, like that right there, I'm increasing my vertical speed so that we are descending faster. See, my vertical speed is supposed to be -79, so I rolled to the right, and that increased our rate of descent. So I'm trying to just keep my vertical speed here matched up to where it should be according to the reference. If I can do that, then that will ensure that we maintain the proper altitude, you know, throughout the descent. All right, so we're doing another roll reversal. Delta azimuth is climbed way up to -14 in that direction. Hop over and look at base sync. See, we're over 500, almost 550 kilometers off from the base, so we'll turn back and start heading back over to it. If I pull up the map MFD, you can take a look at what's going on here. Let's see. Let me move over a little bit so you can see Florida there and down. So you can see where we are. We're kind of in the middle of the states at the moment, and our trajectory is taking us over here to the right because we were turning to the right. Now we're turning back to the left. So, you know, our trajectory is essentially just going to do this number. It's going to go back and forth, and then eventually, as we're almost at the base and we're done with our S-turns, we should have our trajectory pointed right at the base again. So that's the idea of what the S-turns accomplish. You can hear we're falling into more of the atmosphere now. The dynamic pressure is building. It's getting louder. But also take a look at the map MFD. You notice this trajectory here. You almost tend to think, oh, well, this is where I'm actually going to hit the ground. That's not correct, and I don't know why the map MFD does that. I'm sure there's a reason, but I don't know. I can't tell you, unfortunately. But if we were going to fly Buck Rogers style and try to re-enter just using the map MFD, you can see how that would not work. It's incredibly difficult. It's pretty much a guessing game, honestly, because this is not accurate for telling you where you're actually going to hit the ground. So anyways, let's jump back over to Glideslope. And alright, so we're pretty much covered everything here for the moment. And vertical situation. So our delta azimuth is climbing up quite a bit now, so we'll probably do a roll reversal here in just a bit. But our altitude and our airspeed is pretty much on track. We're looking pretty good. Notice I'm putting the air brakes out during the roll reversals. That's you press B on the keyboard to extend it 50% and press B again to extend your air brakes to 100%. Alt B retracts your air brakes. So I extend the air brakes during the roll reversal because we're not decelerating as quickly as we are during the S-turn. So when I'm banked over like this and pulling back on the stick, I'm increasing, you know, our rate of deceleration. But whenever I have to point the vessel forward again and roll over the other direction, we're not really slowing down nearly as much. So I deploy the air brakes during that process just to help keep our speed under control. So you kind of want to roll over, you know, as quickly as you can, but you don't want to obviously just sling it over real quick because you could rip the wings off the aircraft. So that would not be good. Alright, and let's see, we're looking pretty good. We're about 1,000 kilometers from the hack, or 1,000, just under 1,200 kilometers until touchdown. Energy's looking good. All this is in the green, so this is good. Again, I'm not concerning myself with the angle of attack just because of the limitations of the Delta glider, but if you're flying like the XR2 or something that has an autopilot, you should be able to keep this within, you know, ideal parameters, within the ideal range, I should say. So our Delta azimuth got up to a pretty high number there. Generally, I take it around 10 degrees, maybe a little over 10 degrees, and then I'll turn back the other direction. But as we get closer to the base, you don't want to make quite as large of an S-turn. So in other words, you don't want to bring your heading so far away from the base, because once you get closer to the base, your speed is a lot lower. And so, you know, if you bring your heading too far off from the base, you may not be able to get back over there. So, you know, once I get, you know, within a reasonable distance of Florida and Cape Canaveral, I'll start doing smaller, tighter S-turns in order to continue to brake, but just keep my bearing toward the base a little closer. Alright, so we'll just proceed with this reentry. We're going to do a roll reversal here, extend the air brakes, roll over as expeditiously as I can, and then retract the air brakes and pull back on the stick again. Again, using your elevator trim here, putting it all the way up, will help you with pulling back on the stick and help you with that braking maneuver throughout the S-turns. Alright, so we are almost to the 500 kilometer mark until the hack. Our total energy is pretty good. It's in the green, so we're looking good at this point in time. You'll see that our airspeed and our altitude actually converge at this point. This is getting pretty close to the base by here. Alright, you notice that during this S-turn, see now our trajectory is taking us here. We'll go a little bit tighter S-turns, just back and forth like that. Let me jump back over to Glideslope here. And what I'm going to do is, it's a little early, but I just want to show you for demonstration purposes. We'll press mode until we get to the horizontal situation mode. And if I zoom out, you can see, so this is our trajectory here. And this is our planned trajectory. We're supposed to be flying like this straight toward the hack, and here is the hack, the circle. So we fly like this, we complete this circle like 360 degrees around, and then come down and land at the runway at the end there. You'll notice this little arrow right here, it's moving over that direction because I was turning to the left. It's telling me I need to be turning over to the right in order to stay in line with the hack entry. And it's the same thing you're looking at here. Here's the degrees to the hack entry, and here as well. But this on the horizontal situation screen gives you this nice little arrow that tells you, you know, the direction you're off from the hack. And so I can tell if I turn to the right, I'm bringing that arrow here toward the middle, and if that arrow is right in the middle, I'm heading right toward the hack. You'll notice these these pluses right here indicate our where our velocity will be taking us. And obviously I'm turning to the right, so the pluses are curving over to the right, but they're going to help us fly around the hack. Nice little inverted roll reversal there. Now we're going slow enough that you know, I could get away with doing that, and my airspeed was a little high, so by doing an inverted roll reversal, it increased our rate of descent just a bit to help slow us down just a little bit more. So you can actually see Cape Canaveral just ahead there. Our airspeed is now under 2,000, and we are very close to the base. So at this point, I'm a little high on speed and energy, but I'm just going to go ahead and turn toward the hack. Let me zoom in. So I'm ready to, I'm approaching the hack. You'll notice this flashing asterisk here. This is to bring our attention to the impending entry to the hack. So ideally, when you're 30 kilometers from hack entry, so when this reads 30 kilometers, you want your altitude, your airspeed, your delta azimuth, and your energy to all be on target to where they should be according to your reference. If you have that all on target, then you are set up to fly the hack perfectly. We're actually, you can see I'm clearly fast, I'm high on altitude, and I'm high on energy. But I'm just going to go ahead and fly the hack as is. So I'm going too fast to make this tight of a turn. So I'm going to end up making a much wider radius turn here. Now it is possible to increase the size of this turn radius. So you can increase the size, and you can also change the shape of the hack. You could change it so that you don't do a full 360 circle, so you essentially just turn around and land. There's a lot of different options. I'm not going to confuse you with all that right now. I think that would be better on a tutorial of its own, and quite frankly, I'm still learning all of this. Flying the hack is actually a lot harder than you might think. So as a beginner, I think for you the hardest part is figuring out how to re-enter in such a way that you've managed your energy so that you don't overshoot the base. You essentially slow down exactly over the base. But we are basically here. If I jump out real quick, I mean, there's the runway right there. And we have more than enough altitude and airspeed that we could easily just do a couple of tight turns and then descend and drop down right to the runway. So if you've gotten this far, you don't have to do all of this hack turn and everything if you don't want to. I just thought it would be cool to attempt to do one for the video here. It's an incredibly sloppy hack turn, as you can tell. I came in with way too much speed, so I ended up coming way out here. And so I think what I end up doing is I turn a little tighter turn, and then I cut the corner over to the runway because I get a little low on energy. But you can see here actually, where I'm supposed to be. My altitude is supposed to be like this throughout the hack, and my airspeed is supposed to be here, and I'm off. I'm off target everywhere. And then also my total energy here is in the red. So this is indicating to me that I'm negative 21.5% short on energy to fly this full hack and still make it to the runway. So there is options where you can change the shape of the hack, you can change the size of the hack, and in order to, if you're short on energy, by changing the shape of the hack or the size of the hack, you can bring your energy. You can make use of what energy you have. But again, I'm not going to confuse you with all that and how to do that. So at this point, I think as a beginner, you're going to be just stoked to even be here at this point, and having made it this far, pretty much realistically anyways as well. On top of that, the tutorial really isn't going to help you much more as far as landing. That's just going to be up to you. If you have any experience with flight simulators, as I have before finding Orbiter, you should be pretty comfortable with landing on a runway. But we'll go ahead and bring it in for landing and wrap up this video for you. So I guess nice thing about the playback, we can hop out, take a look around. So here we are performing this nice long slow circle. I mean, we're still up. We're just barely under 40,000 feet in altitude. So we're still up as high as commercial airliners. So we're just scrubbing what little bit of speed we have left along with our altitude in this gradual descent down to the runway. I'll zoom in on the hack. You can see, I mean, how sloppy that is. It doesn't even look like a circle. But we will go all the way around here and then come back to the runway. Oh, so just hang in there for a minute if you want to see the landing, and we'll hopefully bring it home in one piece with a nice smooth landing on the runway. One of the cool things about Orbiter 2016 is the new atmospheric effects in the realism settings. I found that it actually makes it incredibly difficult sometimes to land because of the wind effects, and you'll see that as we approach on final. You'll notice that our velocity vector actually takes us one way while the wind is trying to push us another. So I don't think the weather aspect of Orbiter It's certainly not as realistic as Flight Simulator is, but the fact that it even has, the wind thing now, that's pretty cool. So it just adds another element of realism and difficulty when you're talking about bringing it home, especially in this case, because even though we have fuel left, I would like to bring it home purely on gliding power here. It's especially rewarding when you can do a full unpowered reentry and landing back at the base of your choosing. Obviously, it is incredibly difficult to do that in the space shuttle, especially if the space shuttle doesn't have autopilots like the default space shuttle. Although the default space shuttle does now have a launch autopilot, I don't believe it has a landing autopilot. So I know some of you have expressed some interest in doing a flight with the space shuttle, so I'll definitely have to look into that. I think that could be a lot of fun. It is incredibly difficult to fly the space shuttle compared to the Delta Glider. It's not as forgiving, so as a beginner, it's definitely not the first thing you want to jump into. And that's the reason that I really focused on the Delta Glider for this series. It's a lot of fun to fly. Alright, so that was a terrible hack turn, but you get the idea. It gave us a nice little gradual controlled descent, and now we're going to just move down for a final approach to the runway. Got the vehicle assembly building ahead of us on the left there. We really don't need this anymore. We should be focusing on the runway at this point, so I'll bring up the surface MFD for the remainder of the flight. And at this point, if we need to control our airspeed, we can always extend the air brakes. And there they go. Press B on the keyboard again to do that.
You are cleared to land.
Alright, we're cleared to land. Alt B will retract the air brakes. 2,500 feet, so we will drop the gear at 500 feet. Again, we're landing on runway 33 here at Cape Canaveral. Notice how the velocity vector is kind of taking me over to the left, and I'm trying to get control of it. That wind is brutal. Alright, we just passed 1,000 feet a moment ago. Waiting for 500.
500.
There's 500. Gears coming down. Press G on the keyboard.
300.
Pre-flare coming up.
200. 100.
Alright, here we go.
50. 40. 30. 20. 10.
Wheels down. Well, it's not as smooth in the playback as it was when I actually flew it. I guess that's not ideal, but anyway, we touched down relatively smoothly. We're not on the center line, but we are in one piece. We managed to re-enter pretty much realistically. I also forgot to mention, but I talked about the load MFD. I can pull that up real quick here. If you open the load MFD and you press U and I and LOA, it puts the G loading up here, which is pretty convenient, so we don't need the MFD opened anymore. You can go back to whatever MFD you want. When I performed this reentry and I recorded, the playback, this worked just fine, but I noticed when I played the playback so that I could record it on the video for you guys, that this did not indicate the proper G loading on the vessel. So I didn't bother opening that because it would just be telling us, like 1G or something, and we should have been pulling like 5Gs at some points. So I don't know if that's like a bug with that MFD or something. Maybe I'll have to contact the developer of it. But definitely it's a cool, very cool MFD to have. So if you want to, install that for your reentries so you can better monitor the G loading on the vessel and keep it at realistic levels, it just adds another level of realism for you. But anyway, listen, man, I really appreciate you guys hanging in. It's been quite a long flight, but we are back, safely. And I'm not sure which one I'll do next, but we'll definitely pick up somewhere, maybe the space shuttle or maybe a quick XR2 flight or something interesting. And listen, thank you for the comments and likes. I appreciate all of that, and hope you guys are doing good. Take care, and we will see you in the next video.